we defined class data structure into two parts, linear and non-linear. In linear data structures, there is static type of data structures like arrays, and there are because why it is static, because if we define any array, then the size will be fixed. But nowadays there are dynamic arrays also, where we can like manipulate the size after defining it again.
Mm.
And in dynamic data structure, queues, stack, linked list are there. There can be other also. In non-linear data structure, trees and graphs are there. It is linear because we can see that all of the data are in a sequence, and in a tree or graph,
We can
uh,
see, or it will store the data on
no,
sequence.
no, no. Storing the data will not be necessarily be in sequence. It can, I'll tell you like in different data structure how it is stored. In tree and graph, those are connected like if if you imagine they will be connect. You cannot imagine in a sequence. In
I have one doubt.
Yeah,
It's written like linear data. Each element is attached to its previous and next adjacent elements.
yeah,
No,
some kind of relation you can say.
Or
that is non-linear or linear.
they are saying it is linear.
No, it is non-linear.
No, no.
No,
Here in
linear.
linear data structure, we can say some kind of relation it can have to previous and next elements.
But what kind of
L-
attachment?
l- Yeah,
Like,
like in arrays, those will be sequentially stored in the disk. It has a relation like only after one address completion, then other variable will be stored.
No,
Like in
I
linked
can
list,
store. No, I can store A of 0 separately, A of 2 separately. No.
but the address of A of 1 will be after A of 0 only, like in arrays.
Yeah, I mean, so. Mm, 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 mm. Attached to the previous and next adjacent elements. Okay.
Okay, so why we need data structure? Like modification is easy, saves memory space, representation is easy, and require less time. And we need to choose what type of data structure we need according to our problem. So we'll start with arrays. Arrays is a linear data structure, and it stores the data in contiguous memory location. So let's say a memory location address is 200. Then the next if we store something in at the first position, then the next at next position it will be stored after, like how many bits it will take. Like integer will take
Mm.
4 bytes. So after 4 bytes of location address, next would next variable will be stored.
So basically, then sequential, the memory location is sequential, right?
No, no, not necessarily.
no,
In arrays it is sequential.
Okay, okay. Only in arrays.
Yeah,
Mm.
the next data will be stored just after the previous element.
Mm, mm.
And it will be like for integer 4 bytes are there. So after 4 bytes of address space, next element will be stored.
Yeah, yeah. I mean, basically, when you are defining itself, if you are
Hmm.
defining A of 5, A of
Yeah,
integers, so that
yeah,
much space will be preoccupied and it will be filled with the elements there when you're initializing.
yeah, correct.
Yeah.
And in arrays, since they are sequentially arranged in the disk, we can directly access any elements in the array.
Mm.
That is one benefit of array, because it can calculate in background like this address will come off. Uh, Generally, it stores the base location only, and when you ask any other position's value, then it will calculate in background from the base location, like from base address, how much far it will be, and it will add and give the output.
Mm.
So arrays will have only similar type of data store. If you can store only one type of data type in arrays, every element should have similar data type, same data type. If you want to search any element, it will take order of n because we will have to traverse through complete array. Insertion and deletions. If you want to insert at any other position, then it will also take order of n time. Deletion will also take order of n time. Updation will take order of one time because you can directly access any element. But if you want to find then update, then it will take order of n time. Okay. General applications in many problems like will define arrays only for storing any type of data. It can be also used for CPU scheduling, lookup table in computers. There can be many applications of arrays. Okay, we'll go next. Linked list. Linked list. So linked list is also a linear data structure, but these data are not sequentially stored in the disk like in arrays. In
Yeah.
linked list, there are mainly two parts. One is data, and the next part is the address of next element of the list. So in data part, we can define any number of data like integer, string, any type of data that we want. And and in the next part, we will store the address of the next element.
Mm.
So if we want to traverse, we can traverse sequentially only, and we cannot go directly to any position in linked list like in arrays.
Yeah. So here, for example,
Yeah.
now this
Mm.
has a, I mean, first one, like for example, if I define a as a integer value, and then
Yeah.
next as a same object a pointer.
Yeah.
So how much, like for integer linked list, how much
Mm.
size for each node will be occupied?
Okay. For any data type like A is integer, then 4 bytes of it will take 4 bytes,
Mm.
and the it will next part is address only. So in C++,
Mm.
address is of 1 byte.
Mhm.
So total this one node will be 5 bytes.
Okay. Mm. Okay.
Okay. So there are various types of linked list like singly, doubly circular, doubly circular. Singly linked list is like this image is only singly linked list
Mm.
where previous element is only connected to next elements and no other relations are there. In doubly linked list, the next element is also connected to previous element like back arrow.
Yeah.
Yeah. And circular linked list, the last element will be connected to the first element. And in doubly circular linked list, similarly, like it will be doubly linked list and last element will be connected to first.
Mm.
And linked list are used at many places like in okay in memory management, we need to find where are the free spaces. So that free space is usually stored in linked list in operating systems. So it will have the amount of free space and the location of the next free space. What are the operations we can do here? or inserting elements, it will take order of n time because we'll need to go to the last to insert any element or any specific position. Deleting elements will also take order of n time because, because we need to traverse to that element. Searching is also order of n, updating order of n. Can only traverse from first to last and we cannot directly access any element.
So in deleting in the sense here, you just need to remove the link and then attach it to the other,
Yeah,
right?
correct. But
Then,
we need to go to that element.
then what will happen to the deleted one?
Okay, so uh, like if you don't, if you use C++ like anything, if so it will automatically remove that space, or you need to if you define manually all those nodes, then you need to delete those nodes separately to free the space.
Okay. I mean, generally, even that's a object with the data, right?
Yeah, correct.
So ideally, if you delete the connection, it'll
Mm.
be independent somewhere.
Yeah, it will be present somewhere if you do not free the space.
Hmm.
There are various applications of linked list, like we can implement stack queues, graphs, and it is used in linked allocation of file memory management,
But
and we can
in real time, what are the use cases for linked list?
linked list, like one I told, it is used in operating systems for memory management.
Hmm.
And a link here, real life example applications are given in linked list is used in round robin scheduling to keep the track of multiplayer games, or we can use linked list where only previous and next function is there, like in an image where you can only go left or right, we can use linked list there also, or playing songs, if you want to go next or previous, we can use linked list there to attach next and previous songs together.
Hmm. Hmm. Okay. So, like for example, if I am retrieving some data from
Yeah.
database,
Hmm.
so generally what I do is I just create an array and I'll uh, query the responses from database and I'll assign that array with the result set.
Yeah, correct.
So, but like in any data now in real time application, we store them in database.
Hmm.
So now, or in a file systems, like either database or in file system somewhere, right? So
Okay.
now where can we use this linked list in real time? Like you told, for example, you told image viewer.
Yeah.
So yeah, that files may get stored in the uh, file system. You might do ls to that, but ls will give list of file names in a list format only, right?
Hmm.
So I mean, what how can we do it? I mean, what is the advantage of using a linked list over arrays here in image viewer only? So
Okay.
we can have songs assigned in the dynamic arrays, right?
Yeah.
So there, I mean, um, it can, I mean, based on the user clicks only, we'll play the songs.
Yeah.
So,
It is given like one example we can use, but if we compare to arrays, it will be more faster. But there are dynamic arrays now,
mm,
so that is more preferred nowadays rather than linked list.
so any more examples that you can give apart from image where playlist, I mean, playlist, these things in normal functional scenarios kind of thing.
Okay, I'll need to search examples of that.
Okay. Okay. Yeah. Go on.
So next is stack. Stack is also a linear data structure, and uh, sh- pick- we enter the data in stack, and we can only access the top element of it. It is the last in, first out func like a data structure where every data we enter and we can access only the top element. We can perform like push. If you perform push or pop operation, then on there are only two operations in a stack, like push and pop. If you do
Mm.
push, it will be pushed to the top of the stack, and if you do pop, it will remove the topmost element only. So we can access the elements in sequential here also. So
So this here singly linked list will be used as a reference, right?
we can use simply list to create the stack.
Mm.
Stack are used in many algorithms like tower of an eye or retraversal or recursions. Many problems when using a stack, it becomes more faster. Like we can design an algorithm which runs in lesser time complexity using a stack.
So what will be the time complexity of stack?
Okay, there are only two operations, push and pop.
Mm.
Uh, the push time complexity of push will be order of one, pop will be order of one only.
Okay.
Yeah.
And we can check size or is it empty or not.
So those are the available methods, or
If you use like predefined stack methods, like
mm,
in STL and C++, those are available methods. Or
mm,
if you want to create a stack using linked list or other things, you
okay.
need to create these functions.
Yeah, understood. And basically, whenever we want to push, we need to create one node and
And
assign
attach
it
it to
to
the last.
last element and attach that as a head. I
No,
mean,
why head?
assign that as a head. Yeah, when we are pushing it,
Yeah,
so we will attach that to last node,
yeah, correct.
and
And
uh, and that we need to
we
mm,
we will do operation only on last element, na? So
mm,
it's done
mm.
if we attach it to the last only.
For pop.
Pop also will remove the topmost element only. So if we do pop, the last element will be removed.
Yeah, yeah. But I mean, what I'm telling is for push, if you don't assign anything at the last, I mean, you have to traverse through entire linked list, right? To find the last element and push it.
It will, if we push any element, then it will automatically go to that element. Na? We'll always have a iterator there.
Basically,
Yeah,
first element in linked list will be pushed or I mean popped.
not first element. Like here is a list. If we add, if we want
Yeah.
to create a stack, if we add, it will be added at the last.
No, it will be added at the first. No.
You can say like if you add here, then how will you? It will be like take more time complexity.
How, like, this will only take more complexity, no? I mean,
No,
adding at the last because you have
let's
to
say
travel through.
if we have five elements.
Uh,
Then if we inserted one, we reached here. We inserted second, we reached here. Whenever we insert any element, the
No, no.
pointer will
What
be
I'm
to
telling
that
you,
element.
no, no. I'll have a, like, for example, here I want to insert a ABCD is already there. Okay.
Okay.
I will insert X. So it will become XABCD. And
You,
I want to insert Y again. It will become YXABCD.
okay. But what was the sequence of ABCD? How did you inserted ABCD?
ABCD here, like whenever I mean, now, for example, this list stack is already there. So if I
Like
want to
how
insert
inserted this ABCD? First A, then B, then C, then D, or first D, then C, then B, then A.
first D, then C, and then B and A.
How will you insert first D, then C, then B, then A?
In this case, it is ABCD is ordered in this way. But when I am inserting as A will come as a last here.
Yeah, last,
A will come as a last. B will become in front of A,
correct.
and C will become in front of B. D will become in front of C, so that
Yeah.
I can remove first element for pop and assign again.
Pop will remove the topmost elements. Here D is the topmost element.
But for me, D will be the first element. No.
How?
Yes.
First you like inserted A, then then B, then C. If you insert D, it will be at top, no?
So you are having one more reference pointing to C, right? Here
One more reference from where?
in this, if you see push one,
Hmm.
you are having a top assigned to C, no?
If you push, top will be C.
Top assigned to C.
Correct. Yeah.
Top C is one node and top is as a reference, it is referencing it to C.
Yeah.
So, but I don't need this, no, basically.
I didn't
For
understand
example,
what.
I'll share my screen. What I'm telling was, okay. This is good one. So first, this is empty. Like, okay, currently nothing is there as a stack. Okay,
Yeah. Okay.
so one element was there. So I think you ignore this. Okay,
Hmm.
so A here null is there, and then when I'm having it, when one more element is being pushed, B, and I'll have a
See, you
map
are
connection here. This null, this next is assigned to this node.
okay. You want to do this way.
So this I'll have one pointed like, okay, now this is top. Okay.
No, no. If you pushed B,
No,
then B should
wait.
be at top.
Correct. First, initially, this is top. And
Okay.
then top is moved here.
Yeah, correct.
And then one more I'm having C here. C will be mapped to this one. And then I can simply map it to this entire top, to this top. And then top can be moved here, no?
This is what I was saying.
So now when I am just removing it, I can remove this and top can be shifted here, right?
Correct.
So in this case, no, in this case that you are presenting,
Okay, the arrow was reversed. Okay, got it.
I mean,
Okay, okay.
okay, anyway, you are referencing top. That's not the issue, basically.
Yeah, yeah. Got
But
it.
if
What
you are
what
not
you are saying.
referencing the top, you have to traverse from A, B, C, anything, right? So here you have a top here.
Yeah.
You are deleting this.
Hmm.
Then how the top will be assigned? There is no pre-pointed, no here. You can't go reverse, right?
Yeah, that you showed that previous diagram that will be only implemented.
Okay. Because it's not a doubly linked list, it is a
Yeah,
single linked list.
correct.
So in this case, like we can't traverse it.
One in stack. That is one advantage.
Mm.
Then queue is there, which is first in, first out. The first element that we pushed will be popped when we use pop operation. This is if this is the first element. If we add another element, this it will be added here, then here. But if we do pop, the first element will be removed. Then if we do again pop, then this four will be removed. This can also be implemented in linked list.
Yeah, here basically we need to have two references. One is at the starting and one is at the ending.
Yeah,
Ending is to
correct.
add and increase. Starting is to remove and decrease.
Hmm.
Ashika, you are getting it?
I got it.
Mm.
It has uh, it also has two functions in queue. If we want to add any element, it will be added in order of one. DQ, if we want to remove any element, it will also be order of one. It will remove element from the front, and NQ will add element at the back. Peak, like if we want to uh, print any element at the top at the front, it is also of order of one only, and we can check if it is
Can you
empty or
explain speak, Atul? Like, I didn't get what to speak.
like it will only print that frontmost element.
Okay, fine, fine.
Yeah, it is like a general function given. Peak is not in C++ HTL. We can define that peak.
Okay.
Okay. Then trees are there. So these were linear data structures where data are stored in a sequence. Sequence means the address will not be in sequence, but the data will be stored in a sequence and we can access them in sequence only. In then non-linear data structures are tree, graphs, and various type of trees are there. In a tree, the elements are arranged in a tree-like structure. Like here you can see, first element, root element have many other nodes attached to it, and other nodes will have many other nodes attached to it. So what is the benefit of having tree like a data structure? Anyone? No?
I mean, we can differentiate complete half. I mean, we can rule out complete other half based on some conditions.
No, traversing
Okay.
is faster in trees, right?
How it will be faster?
Because here, like previously in linear data structure, right, there is a dependency onto each element. So if you have to traverse to ninth element, then you have to traverse from 1 to 8 and then you will get the reference of 9.
Yeah.
But here, like we have to, like, for example, if you want to access this element, right, you need not go through each of the element and then come here. This, like you can traverse it faster here.
Yeah. Okay. This can be one thing. Okay. So by using tree and graph like data structure, uh, we can represent the data which are more related to each other. Like let's say there are some cities and roads. We can say some cities will be vertices, and we can attach the nodes using by saying this is a road. So we can have a relation between the data by using this type of data structure. Like in in Facebook friends, all friends will are connected using graph like of data structure only. So a tree will have a node, edge, and root from where it is being started. And difference between tree and graph will be like Um, it will not be connected to if any one node will not be connected to itself, and there will not be any circle-like structure in a tree. Here, like in a graph, it can have any circle-like structure, but in tree, we cannot have any circle-like structure. There are many applications of tree, like implementing other data structures like heap and binary trees, B trees, B plus trees. Many other data structures are implemented using trees also.
No, go to tree diagram once, no once. So you told, I mean, we can't have a circular, right?
Yeah, correct.
So why can't we, like, for example, if we want to attach, why can't we attach this 17 in, I mean, 17, one of the node to that 11 here?
Then we will call that it is not a tree, it is a graph.
Oh, okay. I mean, basically, even here, it's a doubly linked list only, no? Like left and right, you will point it to some of the other data.
Not doubly linked list, but it will have two pointers, left and right.
That will
One is data, another is left for the left node, and one is for the right node.
correct. That will point to the other tree endpoints,
Other nodes, yeah,
other
correct.
nodes. Yeah. I mean, in fact, that's a double linked list only, no?
Doubly linked list we say for a specific only that is attached to its previous element.
Even this is attached to
Like
previous element,
front
whatever we
element
inserted.
will not be, if it has previous link, then will call it a doubly linked list.
Okay. Mm.
In general implementation of a tree using linked list, we'll have a value, any integer or anything, and it will have two pointers for the left and the right.
Okay.
And insertion will take any idea what will the order of insertion, these things, insertion, deletion.
From root to
Yeah, you will have a root node at the start. You want to insert some element.
leaf.
What will root to leaf what?
I mean,
Let's say height of the tree is h,
height in the sense the level of this.
number of levels.
So here
This,
four here in the sense.
yeah,
Okay, like where, I mean, where do we want to insert?
take the worst case only.
Then we will traverse through the root,
Yeah,
will reach end by end. If there is no endpoints, there is no child to that tree, then we will insert there
yeah. Worst case will be attaching element at the leaf node.
at the leaf node. Yeah,
Yeah. Then what will be the insertion time complexity?
it will be order of n.
N is number of nodes.
Then here
Yes.
order of h it is.
Yeah, correct order of h. We'll only need to traverse this height only.
Hmm.
So for insertion, order of h. For deletion, if you want
Deletion
to
also
remove any node,
worst case order of h only.
yeah, correct. Search will be also order of h.
Order of h.
Hmm. And calculating height will be order of h. Depth, same. Okay.
What is it balancing?
Uh, Balancing is like this is not a balanced tree. It will be balanced if it has same number of nodes at each same number of child nodes from parent node.
Okay.
Data structure in game development, also indexing.
Yeah, a decision tree in machine learning. We can say the tree is used there.
Domain names are also used through data structure.
Yeah, correct.
Domain name server, I think maybe the top level domain, then subdomain.
That is being implemented using this tree only.
Okay. Mhm. Hmm. Using the most common social. Okay.
So then next is graph. It is also a nonlinear data structure. The difference between tree and graph, I told like it ha can have circular like structure. Any element can be attached to any other elements. So mm, what can be the applications like representation flow of computation, modeling graphs, resource allocation graph. Okay.
Tell me an easy example for this, no?
Do you remember deadlock in operating system?
Yeah, yeah, yeah.
Yeah, that deadlock. You can imagine that deadlock using graphs.
Okay.
Like which did you get it or not?
I know deadlock in OS.
Yeah, similar like a structure. We can
Mm-hmm.
implement using graphs.
Okay.
In the trees ones,
Uh,
so there it has three childs, no?
yeah, it can have any number of childs.
Number of childs. But here, I mean, do we need to define how many childs it can have, or how it can, I mean, now how it is able to point four children's here?
Where? Yeah, here, okay.
Uh,
So other children will be only null. Here, let's say four pointers are there for root node. Here, two only there. Other two will be null.
so I mean, we need to define like four pointers if we have.
Yeah, correct.
Okay, okay.
That structure is fixed for a tree.
I mean, if that we need to decide how many childrens that tree is going to have, and based on that node we need to define those many pointers, and we need to
Yeah,
start filling those pointers with the child data that it comes.
yeah, correct.
Okay, okay, okay. Got it. So in case of binary tree, it will only have a two pointers.
Correct.
Okay.
But it need not to be same for every other elements. Like you can define any a new node here after this, which can have only one pointer and it can point only to one element.
Yeah, I mean that could be different class altogether.
Yeah, it can point to any other address.
I mean, different class are struct in case of CA.
Hmm.
Mm.
So what are the operations in the graph? We can add any vertex, add any edge. What will be the time complexity here? Adding vertex or an edge.
I didn't understand what is vertex only.
Okay, okay, sorry. Any node we in a graph we call it as a vertex only. And edges will be any connecting line between any two vertices will be an edge.
In general, what is vertex meaning?
Node, end, no? Vertex,
Yeah,
it is end. Like usually, if you have a corner, the three corner will like the three corner,
Three
it will join to one
vertex.
corner, no? That is
No.
vertex.
Okay, yeah, yeah. Mm.
So adding vertex and edge, what will be the time complexity?
Mm, mm, mm. This
Can
is
you explain like how do we traverse in graph? Like there is no root or anything.
Okay, so in a graph, we every node will have information about what other nodes are connected to it
Okay.
using any data structure that we like. We can use arrays, we can use list, anything. It will have like this edge, zero node will have information like there is one edge from 0 to 1, 0 to 4. Mostly we'll use matrix like of data structure using arrays. We'll create a matrix where each of the rows, like there will be n cross, if there are n vertices, then it will be n cross n matrix where each row, like first row will have information about whether it is connected to other nodes or not.
so in trees are there. I mean, in trees we have always root pointed to the top element, right?
Yeah, correct.
Here, what is the first element that it can traverse? I mean,
We
to
can
start
choose
with.
any element.
Is it? Like
Now,
I
how?
remember in DFS, BFS problems, right?
Yeah,
I think they usually mention like usually the problem would be defined in such a way that they'll tell if you choose this, then what? Like in that way, right?
yeah. We'll need to choose any vertex from where we need to start according to the problem only.
So I think
But
it is well defined previously only that from where we should start. It depends on the problem. Based on that, we will choose from where we have to start.
no, in many problems, like we can choose any element to start and we can reach to the solution.
Okay.
It, yeah. But the problem is prepared like this only, so we need to choose that element.
Okay.
But in tree, we'll need to start from root only.
Then
Hmm.
order of complexity will be order of n.
Yeah,
Right.
correct.
Because each will be connected to only one. And if we choose
Only one. Sorry, it can have
no,
any number of connections.
in worst case, like zero,
Okay.
1, 2, 3, 4 is the path.
Correct. In worst case, it will be a tree.
It will be a tree with a single child everywhere. Height is
Yeah,
n.
correct.
Maximum. Hmm.
Adding a edge will also be the same. If we want to connect to vertex, we need to traverse to from that vertex. Same removing vertex also same edge. Then we have this two operation, depth first search and breadth first search, which we use in graphs. So first I'll tell quickly about depth first search. Like we take any vertex and we'll go from that vertex to all of its edges. We'll start one by one only. Like if from zero, if we choose first this edge, then we'll traverse here. Then from four, we'll choose one edge. Then we'll traverse here, here, here. We'll go till all the depth. Then after completing all the depth, if there is no vertex, then we'll retrace the path like it from two, it came from here. Then if we'll check from here, what are the edges that are remaining. So we need to like uh, check what are the vertices that we have visited. We need to trace the path back and take all the remaining vertices.
Hmm.
Okay. Yeah. So, and in BFS, breadth first search, instead of going to the depth, first we'll traverse all the child nodes from the parents. Like from zero, first it will traverse to one and four. Then from one, it will traverse to four is already traversed, so it will not traverse to four. From one, it will traverse to three and two. Then it will go to 4 because it has been traversed. From 4, it will see all are traversed. Then it will return. Then from 2, it will go to 3, like this.
Can you explain DFS once again? BFS, I got it.
DFS will go like from 0. It will go to complete depth. It can go from 0. Like let's say it travels to 4, then 3, then 2, then 1. From 1, it cannot go anywhere because all of the vertices are traversed. Then it will retrace its path to that vertex where any edge is remaining. I'll create a diagram.
So here in DFS, each vertex will be traversed only once.
In BFS also,
Ah,
every vertex we need to traverse only one.
once. Okay.
We'll keep track of which vertices are being already traversed, and if it comes again, we'll not traverse that again. So from 0, if it goes this way, then let's say it goes this way, it will then check what are the edges remaining. This way is traversed, then it will go this way. Then it has two options, this way and this way. It can go to any, according to our code, it can go to any way. Let's say it goes to this way, but it cannot go here because it is already traversed, right? And it is already traversed. So the traversal will be 0, 4, 1, 2, and 3 in DFS.
So are we marking any flag here to make sure that we have already traversed?
Yeah, we'll have any array or anything that will tell that vertex is being already traversed. If
Okay.
we go here 4, we'll mark that 4 is traversed. If we then here, then 1 is traversed.
Okay.
And in BFS, it will go here. Then the first that is being pushed in BFS, we use queue for implementing. So first, let's say 1 is pushed, then 4 is pushed. All of the child node will be pushed to the queue. Then
Mm.
from first, it will try to go this way, but it is already being traversed. It will no go, do not it will not push. Then 3, then it will push 2. Then from here, it will go to all the child nodes that is not been already traversed.
Okay.
And there are many algorithms for calculating shortest path, connected components, cycle detection. We'll read about them later. Yeah, real life applications like Google Maps. It is one of the most common example of graphs where cities are connected. Many cities are connected using paths that we can represent in graphs. Social network is also, we can say, we can represent using graphs. Okay. So by using these type of data structures, we need to be very problem specific what type of data structure we need to use. We cannot use graph everywhere. Like if we can like take the problem using tree, by taking graph, it might take more space and memory. So we need, if we want to have optimized solution to a problem, we need to choose uh, correct data structures according to the problem. So that is all for today's lecture. Okay.
Okay.
Binary tree is like similar to tree which have only two nodes only,
Two
left and
child
right.
nodes for each parent node.
Yeah, correct. So binary search tree. It is a like a specific type of tree where each left node will be kept smaller and right node will be uh, uh, right child node will be more than the parent node. By having this type of like a data structure, binary search tree, we can quickly go to any elements like in log and time.
Where will this be used? Like binary search tree.
For searching.
Correct.
Obviously. But uh like the main purpose to keep the left child as lesser value and the right child as more value. Like
To to rule out the other half. Like for example, you have list here. If you
uh,
want to search 14 in it, so you will point start with 8. You will, so 14 is greater than 8, right? You will
mm,
traverse right only now. So entire left is ruled out, no?
hmm.
So half of the problem set will be reduced.
But in real life, where is it being used? Binary search tree.
Search,
Okay,
search only.
Yeah, search only, but in real life, where is it used?
we need to check examples in real life.
In
Okay.
real life.
A heap is also a tree-like data structure. It is also being used in a map data structures. Heap is only used. Sorry, priority queue or something. In priority queue type of data structures, heap is used. What is a heap? Like it is similar to binary search tree, but the while implementing heap, we can have two types of heap: max heap or min heap. The difference is that the if we take the smallest element of all the data to the top, then we'll call it a main heap. And if we take the highest value to the top, then it will be a max heap. We'll implement this data structure where we need an like we need to change that if we are doing any operations like additions or deletions in the array and we only want the maximum or minimum value always, so we'll implement a heap. So let's say we have some 10 data and we can have operations like additions and deletions of any other data, and for some operation for some function we need minimum value always. After adding or deletion also we want minimum value. If we have general array like data structures, then we'll have to search again from complete data. So it will take order of n time. But if we implement this heap, then like mean heap will always have minimum value at the top, and we can get that value in order of one. So that is one advantage of implementing a heap. And there are hashing data structures like we can implement custom data structure like hashing. We can use arrays for creating we can create an hash function which will store any type of data using hash. Like if we have uh, large data and we want to store the data in a small set of positions, so we can hash that data using any custom hash function and we can store in less storage. Matrix, I told in graph, we generally create a matrix type of data structure. where each row will have information about what are the relation to other vertices and try. Okay, so try, let's say try is used for collection of strings. Let's say we have an n number of strings and we want to represent all those strings in very space and time optimized manner. So we'll use try data structure where let's say there are four strings and dad and do. Then every similar character at the same position will have like same node vertex only. For let's say and from the root node we can define a node A only for both and for dad and do we'll have only other node D. And from here we can traverse like A and T and A and D.
Dictionary.
Dictionary, sorry.
I mean, example can be dictionary, you know?
Yeah.
Yeah, correct. Collection of strings or any dictionary. Then graph, I told, okay. Most of the data structures are like covered. So any questions?
No questions. So many topics are covered today.
Yeah, we quickly covered those, like we didn't go in depth.
Mm.
So what is the topic for tomorrow?
Tomorrow, okay. Yes. Okay, we can have different type of algorithms.
Directly. You'll not
No,
go
no,
depth with
like
it.
what are greedy algorithms? What are dynamic
I mean,
programming, divide and
we'll,
conquer?
we will
Only like,
solve, I mean, we'll solve some problems for each data structure type, no?
yeah.
And
Okay, for each
before that,
data structure type.
Yeah.
before jumping into algorithms, like how they works, those things, how we can insert, traverse elements, those things.
Insertion, deletion, traversing,
Okay,
of
so you
each
need to
of.
write code for that, no?
Mm.
So how we'll do that?
You need to write in online, compare and show it to us.
Okay,
Because that is the main purpose.
but you all should write yourself, no? By
Ah, yeah.
seeing.
We will write. You just tell the logic and the things to be taken care. Like if you see linked list, right? So top has to be defined.
Linked list will be there will be a
Head,
root node
head,
head.
head, head has to be defined first.
Yeah, correct.
Then only you can create the first node and then you assign it to head, assign it as head.
Head can be any random node. You can define.
For traversing purpose, like first element we'll mark it as head, then we'll traverse and the head will move to different elements, right?
Yeah, correct.
So like you can tell like the basic logic if we are coding, if we are trying to code this particular scenario, then what will be the steps that we will be following? Then we'll write the code as per that.
Yeah.
Okay.
Like in case of stack, if you see, we will have to check whether the stack is empty or not. If it's empty, then we will directly throw exception, right? Or
Yeah.
something saying that the stack is null,
No elements to pop.
no element, yeah, to pop. So those kind of things. They'll be
Basic
brushing.
those CRUD operation. I mean, creating, reading, updating, deleting operations.
Mm.
Then we will, I mean, give us some problems for assignment. Then we'll do it using those operations, and then we can
Okay.
discuss like whatever the problems you give. So you can discuss in the call. So by the time we should be able to solve it and I mean, come to some kind of understanding.
Yeah, you can give it the previous day only. Like
Mm.
next day before we come to the class, we'll write and come. Then you can
Okay. Yeah.
explain. You can give
I'll.
overview that this is the step. Based on the step, we'll write the code. Then the next day you can discuss the code.
Yeah.
Yeah. Okay. I'll send the problem links.
Now, first explain these basic things, insert, update, those things with coding, then give problems.
First explain same thing and then give same problem.
Not same problems, different kind of use cases. Like, I mean, don't directly ask you insert at this place, but ask in such a way that we should be able to understand we need to insert it and then like that.
Okay. Okay. I'll create a list of problem
Mm.
and we'll that tomorrow only.
Yeah, Sunday holiday.